All right, so we need to become proficient at interval notation, okay? The majority of our solutions, especially early on, when we start getting to stuff that is somewhat different or new to us, is going to be answered with interval notation. There's going to be times where we take a function and we say, okay, what is the domain for this function? Meaning, what are the x values that I'm allowed to plug in? Okay. Well, there's going to be an infinite number of x values usually, so I can't write all those down. I gotta have a notation that presents all those infinite number of x values. And interval notation is that notation that presents that. Okay. I might ask you, what is the range, or what is all the y values, what are all the output values that I get from those domain values, from those input values? And there's going to be an infinite number of things, so I have to be able to list those in a convenient way, and interval notation is that convenient way. I don't want to have to use a graph, okay? And a lot of times, we'll start essentially with the graph and say, okay, how can I interpret this and provide useful information from that graph in a convenient, meaningful way, all right? Now, in order to do that, we have to make sure that we understand what all the notation means, okay? If I don't understand what a bracket means compared to a parenthesis, I'm going to get every question probably wrong, okay? If I don't pay attention to chronological order, okay, meaning that the first object that I put into my notation has to be the one that is furthest to the left on a number line, and the second object is the one furthest to the right on a number line, then I'm going to get things wrong, okay? Try to walk you through those aspects as we go through these examples. Now, I talked to your previous math teachers, and you've used this in Algebra 2, okay? But it is so important that I'm going to reteach it and talk about it on a very consistent basis because we're going to struggle in this course if we don't fully understand what's going on with these intervals. All right, so on Friday, I think we did the first two, didn't we? Okay. I just want to rehash those real quick. We did a number line. Okay. My number lines are going to kind of stink right now. But that was 5 right there, correct? Okay. And we use, you guys are accustomed maybe to an open dot, right? So we put an open dot on 5. You put it on top of the number line or above, it doesn't really matter. And then we draw an arrow that direction or a ray that way. And that just is the graphical representation of all my solutions. Now here's my question. If I gave you a typewriter, okay, or even your computer, and I asked you to write out in paragraph form a concept or an idea, or maybe explain your solutions, explain your problem, your technique, and you have to incorporate this. That's going to be a pain in the butt to do with the tools that your computer has, right? Okay. You might take a picture of your cell phone and then cut and paste it and that kind of thing, right? You don't want to have to do that. It would be much easier if I could just go to my keyboard and type in that. Okay? It's so much quicker, so much more efficient, and it tells me the exact same thing. Okay? Essentially, what we're doing, guys, is that this number here is always the first number, whether you're including it or not. Okay? It is the first number that is identified on your solutions. Okay? So when I draw this, 5 is helping me define my solutions, right? Okay? So that's the first number. This is the last number, okay, that I see, and it's got to be in chronological order. It's got to be from left to right, okay? Chronological refers in time, right? Okay? If I'm thinking on a number line, okay, these times should be smaller than these times, okay? We don't want that flipped and say infinity, comma 5. Okay, that means something different. It doesn't really mean anything, really. So that'd be an issue. Is that okay, everybody? Okay. Now, with our notation, okay, I think I left you with this on Friday when the bell rang. We have two ideas. We have what we call inclusion, and we have exclusion. Okay. And the example we just did was exclusion, meaning that we excluded some of the values that were written in our notation. Okay? And the idea is that 5 should not be an answer, right? 5, we have to have 5 in there because there's no way for me to say 5 point and then an infinite number of zeros and a 1. to provide that first number that interval is referring to, that first number that we're allowed to be on this graph. Okay? So we write 5, but we exclude it with a parenthesis. So the notation is less than or greater than produces, you guys know, is an open dot, right? But right now, we're going to use a parenthesis. Okay? So open dot, you correlate that to a parenthesis. Less than or greater than, you correlate that to a parenthesis. All right? And that's exclusion. Okay? We're excluding that number in essentially that idea, that infinity. Now inclusion is different. Inclusion, now we're going to say that 5 does need to be part of my answer. So if I look at this second one here, let me draw it here. Okay, so if 5 is there, and I look at x being greater than or equal to 5, I'm now saying you can be at 5. So you need to have a closed dot at 5, and now it's still the numbers that are to the right, correct? Okay. So now we have inclusion, so we write that with a bracket. We say 5, put a square bracket to the left of it, comma infinity. Inclusion is when we have less than and equal to or greater than or equal to. Graphically, you've probably used closed dots, but a closed dot to us is the same thing as a square bracket. And a lot of times, guys, I'm going to kind of most likely start when we're dealing with just kind of one-dimensional number lines, just a horizontal number line or a vertical number line. I will probably stop using open dot and closed dot. Now, when it's 2 dimensions, we'll have to use open dot, closed dot. It doesn't make a whole lot of sense to put a parenthesis in an XY plane. But I'm going to use a bracket instead of a closed dot. I'm going to use a parenthesis instead of an open dot. Does that make sense? Because then that directly tells me what I need to put in my interval notation. Now, there are a lot of solutions right there, right? There are a lot of solutions right there, correct? Are they the same amount of solutions? There's an infinite number in both, isn't there? But which one's bigger? The second one, because it has one more value, right? What's that one more value that that second one has that the first one doesn't? 5, okay? And that's the issue, guys. When we're writing things by hand, and I'm giving you homework or quizzes and tests, and you write parenthesis 5 and it should have been a bracket 5, you're wrong, okay? I hate to do that to you, but your solutions are not being expressed the correct way, okay? Meaning that you don't fully understand the inequality aspect of things, and that becomes important in a lot of things that we do later on, because there will be situations where I could do a lot of work maybe with the 5 comma infinity in the red there, okay? But that work, because it's exclusive, doesn't maybe work with the stuff that I've written in black, because maybe my formula or theorem doesn't work with 5 being plugged in. Does that make sense? Okay? So we have a discrepancy there, and we have to talk about that. It'd be the idea, if we were going to the courtyard, now there's a finite number of blades of grass out in the courtyard, meaning I can associate a number with all of them. That's probably a pretty big number, right? If I were to take the courtyard, okay, and count all the blades of grass, and then take another courtyard that is the same exact size, but has one more blade of grass, is there going to be a visual difference? Not really, right? Okay? One blade of grass isn't going to change things a whole lot in that aspect. But one value in my interval notation up there that is included or excluded that shouldn't be is going to change things dramatically for us. So we got to pay attention to that. Is that all right, everyone? Okay. When we go to that third one, x is less than 5. X is less than 5. I don't think I gave myself enough room over there to draw all the graphs. So we'll do x is less than 5 here. So I got my number line. I'm going to find 5 on my number line, right? Okay. Now I'm going to put a parenthesis on there. Okay, now I open my parenthesis to the direction that my ray is going to go. It's going to be less than 5, right? So it's going to be all these values that direction. Okay. If you want to put an open dot, but I think a parenthesis is going to help you realize what needs to be in your notation, we change this to interval notation. So, again, we read our solutions left to right. So what would be the first number, because this arrow is telling me other numbers all the way over here, okay? What would be that first number I come to over here that would be a solution? Yeah, negative infinity, okay? So negative infinity is that first thing I'm coming in contact with. And I come through, I start at negative infinity, I come through, and I'll get all the way up to what's the last number indicated that I have to use by my graph? 5. Okay? So I put 5. Now that's the last number I have to use in my notation, but is that my last solution? No. No, my last solution is 4.999999, as many nines as I can say, right? So I need what kind of notation here? Parenthesis. What do I need here? Parenthesis. Remember, infinity is an idea, right? Okay, it's not necessarily a number, so we can never include it because you can never tell me what that number is. Okay, so that's always going to have a parenthesis with it. When we have double parentheses, okay, we refer to that thing as an open interval. Okay, there will be theorems at some point in the course that provide us some rule or some property of mathematics that maybe only exists on an open interval, where we have maybe some x values or something like that, and the endpoints don't satisfy that condition or that rule, but everything between those endpoints would. So maybe at some point we've got like a graph like this, where there's an x value of A, and maybe there's an x value of B. And everything that I talk about will work, and maybe some theorem that will work for every point that is between A and B, but it doesn't work for A itself, and it does not work for B itself. Does that make sense? So they'll say, on the open interval A to B, and it'll write that out in words. So we have to understand that means, well, we're not choosing A and B. Those x values do not get applied to the rule that is being presented. Does that make sense? If they say the closed interval A to B, what do you think that means? You can use both A and B. Okay. So open interval, that brings in the idea that that's exclusion. Okay. We're excluding the endpoints. Closed interval, that's inclusive. We're going to include the endpoints, and that's going to be two extra values that we're allowed to use in whatever property is being presented to us. And we'll see that stuff down. I don't know how long off the top of my head, but we'll see some of that stuff down the road, and they'll just say, oh, on the open interval. Okay. So we got to kind of understand what that means. If I go to the next one, x is less than or equal to 5. So what's the only thing that changes here if it's x is less than or equal to 5? Yeah, that parenthesis turns into a bracket now. So in my picture, we get that. So in my interval notation, we should get the same thing. You see how the interval notation should mimic how you read the number line? Okay. I read a number line, a horizontal number line, I always read it left to right. So when I look at my interval notation, they should mimic the numbers that I read left to right. Okay. Negative infinity obviously is further to the left than what 5 is. Look at this one here. 0 is less than x is less than or equal to 5. There's two things going on there. There's two inequalities. Okay? It's referred to as an intersection, and we'll define this tomorrow as well. Intersection, or sometimes referred to as a between statement or betweenness. Okay? This is the idea. If I've got, 0 is less than x is less than or equal to 5. There's two inequalities there. Hopefully you realize that. There's one right there, and there's one right there, right? Now, because of the nature of the way this is written, okay, it tells us it's an intersection statement or a betweenness statement. And when we deal with that, it brings in the concept of and. Okay? So it's the relationship that x has to be greater than 0. Okay, if I read it from x, this says x is greater than 0 and x is less than or equal to 5. Does that make sense, everybody? Okay. Well, numbers for x that are greater than 0 and less than or equal to 5, we have to have the and part. That means both conditions need to be met, and that tells us essentially that x has to be between 0 and 5, doesn't it? Does that make sense? Okay. So, graphically speaking, you guys might have done this before. If I put 0 there and 5 there, if I just go off of x is greater than 0, you probably drew something like that, right? And if I said x is less than or equal to 5, you probably did something like this. Okay? And now the and idea means that where do those things overlap? Where are both conditions, both inequalities met? And it's met right there, correct? Does that make sense? It's the overlap. Okay? So that's kind of the graphical way that maybe you in Algebra 1 or Algebra 2 kind of deciphered what this meant to us. But now if I want to change that to interval notation, looking at this black graph, left to right, what's the first number you come across? 0. What's the last number you come across? 5. What kind of notation are you use on 0? Parenthesis. Bracket. Okay. Here's a question. And this is just where you've got to kind of think instead of just being a robot and looking at things and saying, well, this is what we've been doing and that kind of thing, and you get yourself in trouble. If that was an open inequality, meaning that dot's got to be open, maybe meaning that's got to be a parenthesis then, right? And then I put a parenthesis there, right? What does that look like? Huh? Looks like an ordered pair. Is it an ordered pair? No. Okay? So it's similar notation that is used in a different aspect of math that is showing up here. We just have to understand that's it means something different in this area than it does elsewhere. Is that okay? Just be cautious with that. A lot of times they'll say on the interval 0 to 5 if it's this is an open interval. Okay, so I mean we don't include 0 to 5. Just be leery of that. That last one then, really the only thing that changes is, okay, now that's included, the 5 is excluded, so now it would be 0 to 5, right? Okay. What I think we need to understand is that is not equal to 0, 5, which is not equal to 0, 5, which is not equal to, what am I missing? Bracket 0, bracket 5, not equal to bracket 5, 0. They all start with 0, they all end with 5, right? But the bracket of the parentheses tells me something completely different. Okay? Each one of those either has one more or one less solution, or maybe one more or two more less or more solutions than the other ones. Okay? And that's a big deal. Even though there's an infinite number of solutions between those, right? If I look at 0 to 5, okay, in any one of those intervals, there's an infinite number of solutions between those. Okay? But when I look at this one, okay, there's one less solution in this set of infinity than there is in that set. Is that okay with everybody? We got to pay attention to that. As we work through our questions, okay, you may occasionally get a vertical number line. A vertical number line. This is, you guys remember domain and range? Talk about that ever? Okay. Domain is basically, if we're talking about functions, domain is just the x values that function exists for. Okay. So if I were just a quick rundown of domain, let's say that that's A, that's B, let's call that point C, that one D. If I were to just draw maybe a curve like that, okay, the domain is going to be written as interval notation between A and B. Does that kind of make sense? Okay. Now if I had an open dot there, and maybe a closed one there, that would change whether I use brackets or parentheses there, correct? Does that make sense? I'll just make them both closed here. Okay? The range is, remember what the range was? If the domain has the x values, what's the range going to be? The y values. And I don't know what the issue is here. I don't know if it's because of the way we read normal text, that when we read the x values, we usually get that right. That's left to right. Okay? But think about how you read a book. You go left to right, but then you start working down the page, right? Okay? So I think a lot of people kind of draw a relationship with that I should read this left to right, and at the same time read it bottom down, or sorry, top down. That's kind of contradictory of what we want, okay? When we read a graph, we're thinking left to right, but we're going to read it from bottom up, okay? Because aren't these numbers down here smaller than these numbers? So that's the kind of the way that we got to interpret that. So when I write my range, which is essentially just our y values, we got to start at the lowest value and then work our way up to the highest. And a lot of people flip those. That's where we get a problem. So if I were to ever give you a picture like this, let's say 0 is there, let's say 8 is there, -3 is there, and I ask you, let's put an open dot here, let's put a closed dot there. I ask you to write that interval notation. Which number do I start with? -3. And I finish with 8. I should have a parenthesis on 8 and a bracket on -3. That's the appropriate way of doing it. Because remember, chronologically, this number, left to right on a number line, because I can take this number line, I can swivel it and make it a horizontal one, right? This number should show up on a horizontal number line first before that one, right? Okay. The number one answer that I get that is wrong is 8, -3. Okay. You got the right endpoints, they're just not in the right order compared to one another. Okay. And that's a huge problem on test quizzes, homework, that kind of thing. Is that all right? Okay, so let's do an example. And guys, the examples that I run through here with you, okay? What is the exponent, largest exponent for x there? 1, right? What's the largest exponent for x there? 1, right? What's the largest exponent right there? 1, right? Okay? Down here, 1, 1, 1, right? All those exponents are 1. So these are all what type of inequalities? Linear, okay? And when you deal with linear inequalities, you address them just like linear inequations, right? And that's what we've been taught in previous years. And ultimately what's going on here, guys, is this is still a graph of a line here. This is still a graph of a line over here. And when we answer our question at the end, we're basically saying, okay, when is this line here above or greater than that line right there in a two-dimensional plane? Does that make sense? Okay, and I'll show you maybe if we have time that graph either today or tomorrow. But you treat it just like a linear equation. But there's one task, one rule that we have to make sure that we pay attention to, and that's what? Okay, we need to flip the inequality sign when we do what? Divide or multiply by a negative, right? Okay, and that's dividing or multiplying both sides by a negative, right? And that first step here, I'm going to multiply through by -4. Does that mean I have to flip the inequality? No, because I'm only doing that to one side. All right, so I multiply that through. I'm going to solve just like a normal general equation, okay? So this is going to be -4x plus 6 is greater than 3x minus 4. It's -1x minus 1. Now I know I'm a person that tries to foreshadow, tries to think ahead, and hopefully you do the same thing. I know that the number one place that people make mistakes is because of that multiplying and dividing by -1. They forget to do that sign change, right? So, a symbol change. So what I do is I always try to make sure that my x's are positive. So instead of moving the one x over, this one here, I'm going to move these over. Does that make sense? And now I'll keep my x's positive so I never have to divide by multiply or divide by a negative number. So now add 1 over, 7 is greater than 3x. So then 7/3 is greater than x, okay? Now, also by doing that, it allows me to show you another situation that people all the time get wrong or mess up. 7/3 is greater than x. You can think about it that way. 7/3 is greater than x. So if I had a number line, doesn't that mean 7/3 has got to be there? And if the 7/3 is greater than x, x is just some arbitrary value. Where in regards to 7/3 would those x's be, on the left or to the right? it'd be to the left, right? So this interval right here, okay, is expressing those values. Anything over there would satisfy the idea that 7/3 is greater than anything that I just drew in that ray, right? You can do it that way. Some people don't like thinking that way, which is absolutely fine. I understand why you would not want to think that way. So they want to flip these. So they do that. They flip it. And now this is where we deal with equations. It doesn't matter because the equation symbol is read the same way left to right and right to left, right? But if I just do this, what does that tell me? Yeah, I just gave all the solutions that are incorrect. Does that make sense? Okay? So I need to make sure that I don't just flip the numerical and variable components, that I actually understand that that symbol,
please pardon the interruption.
that symbol needs to be pointing towards the X.
Those that are interested in doing the gatekeepers, they will be meeting in the auditorium today during Wildcat time. So when the bell rings, the gatekeepers will be meeting in the auditorium if you're trying to figure out where to go. Thank you.
All right, so 7/3 is greater than X. The same thing as X is less than 7/3. I like to think of my inequality symbols as the heads of arrows. Okay? If that arrow is pointing to the X here, then it needs to be pointing to the X down here, right? Now, the overall task, why are we doing this? To write something in interval notation. How would I write this graph in interval notation? What's the first number I come across over here on the left-hand side? Negative infinity. And what's the last number I get to? 7/3. What notation symbol do I use here? Parenthesis, right? What do I use here? Parenthesis. Okay? There's an assignment in WebAssign. It's not going to be due until Wednesday. There's a handful of questions like the one we just did. Okay? There's a handful of questions like the next one. Now, this one here, a little bit different. Okay? But it's a linear inequality, so we treat it like a linear equation. So don't I just multiply everything by 28? And then go through my math, right? Okay? So we've learned how to address that inequality somewhere else earlier in the year. Okay? So even though we didn't see an example yet, I think you can still kind of press through some of those questions in your homework. All right? That's going to be due Wednesday. We'll get enough examples tomorrow that I'm going to keep that due date Wednesday. All right? Interval notation, guys, it is a huge component to this course and any other course that you take after this. Okay? So it's going to be something we want to pick up pretty quickly. Just make things easier if we learn it now.